All right, so today is our last lesson on sequences and series for now. We will come back and look at this topic again before we write exams and tests, because we're going to have a revision session. So don't stress that we haven't done any exam type questions now. Those will still be coming. All right, so we will get to all of that before you end up writing exams. Okay, so the geometric sum formula is the one that's here in the middle of the page for you. All right, so a geometric sum is like an arithmetic sum in that we are adding the terms together, but here they form a geometric sequence. So if I say that 3, 6, 12, 24 is a geometric sequence, I know that it's geometric because there isn't a constant difference, there's a constant ratio. So in other words, if I have a look at this, my ratio, when I divide term 4 by term 3, I get the same thing as when I divide term 2 by term 1. Okay, so 24 divided by 12 is exactly the same as 12 divided by 6, which is the same as 6 divided by 3. So in this case, your constant ratio is 2. So we know that it's a geometric sequence. When we talk about a geometric sum, what we are doing is we are taking these terms and we are adding them together. So we're taking term 1 and we're adding term 2, adding term 3, adding term 4, etc., etc. All right, so just like I can work out a sum to n number of terms in an arithmetic sequence, I can work out the sum to n number of terms in a geometric sequence as well. So that's what this letter SN represents. We saw that last time on Tuesday. All right, so it is the sum of n number of terms. Okay, and again, just reminding you, term 1 is the same as the sum to 1, which is A. The sum to 2 is the sum of term 1 and term 2. All right, so in this case over here, it would be 3 plus 6, which would give us 9. All right, the sum to 3 would be 3 plus 6 plus 12, etc., etc. Okay, so that's what we mean when we talk about summing. We are adding the terms together. A, as always, represents our first term. R is our constant ratio. And N is the number of terms in the series or sequence. Okay. All right, so again, this formula is given to us. It's also given to us in a slightly different way in that it is sort of turned around. So when I say that it's turned around, I mean that it goes A, and then inside the brackets, it's 1 minus Rn, and then at the bottom, it's 1 minus R. That is not actually on the formula sheet, and you won't see it on the formula sheet that the Department of Education gives you at the end of the year either. I've never ever taught that formula. It's not that it doesn't work. It does work. If your teachers at school are encouraging you to use it under certain circumstances, by all means, go ahead. But I think it's just easier to learn one formula and work with one formula because this works in all situations anyway. The other one isn't actually necessary as well. Okay, so we understand what all these different parts mean. What I'm going to do now is go on and have a look at the example. Are there any questions at this point? Anybody who wants to ask anything?
Now is your time, or forever hold your breath. I'm joking, guys, but it is your time.
Yeah.
So just raise your hand and ask, okay?
All right. Thanks, Nolwazi. All good? Okie dokes. All right. So I'm going to... No problem. So I'm going to scroll down. All right. And I'm going to do this example with you. Very, very straightforward. They're asking us to calculate the sum. So find the sum of the first 12 terms of this particular series. Okay, so the first thing that we need to do in a situation like this is we need to say to ourselves, is this series arithmetic or is it geometric? Is there a constant ratio or is there a constant difference? So we know that if we say 6 minus 2, we'd get 4. 2 minus 2/3 is definitely not 4. So it can't be arithmetic. Let's check to see whether it's geometric. So we're going to take 6 and we're going to divide it by 2 and we get 3, and then let's check if we take 2 and we divide it by 2 over 3. When we divide fractions, we have to tip and times, so that would be 2 over 1 times 3 over 2. Those cancel and we get 3 as well. Okay, so that means that it is very definitely geometric. Because it says find the sum, they're telling us to calculate SN. They've told us there are 12 terms. So we set it out as follows. The sum to 12 terms is A is 2 over 3. R we know is 3. 12 terms in the series minus 1 all over R minus 1. Just like that. Okay, so really, really straightforward. 1 mark for subbing in and 1 mark for your answer. Let's just work out what the answer is. And if anybody has a question, then I will take some questions now. Okay.
There we go. A clock is ticking, my people. So if you have a question, you can unmute and ask. And I see Tabile's hand is up. So Tabile, let's hear your question based on the example that teacher Leah just taught us now. Okay. If you didn't understand, ask now so that you can understand.
Hey, ma'am, I've got a problem here. I can't see the board.
Oh, okay. Go for it,
Tabile,
Yolanda.
no, it's okay. Tabile, I think when it's in that case, log out because you can hear us. Log out and in again and let me know on the chat if it's fixed. Okay. So that should fix your problem. Okay, Tabile.
Oh, okay,
Thank you.
okay. Thank you.
Okay, so now what I'm going to do is I'm going to give you guys an opportunity. There we go. Aheen, quite right. Absolutely. So Tuli, yes. So what you did is you just press the SD button. Nothing wrong with that if you don't, if you want to leave it as an improper. Perfect. Okay, so now what I want you guys to do is I want you to try this on your own. All right. So if you haven't already, you can write this down or take a screenshot. Screenshots are really, really helpful. And then we're going to go down and we're going to have a look at a similar question, and you're going to do exactly the same thing where you're going to calculate the sum to n number of terms. Tiny, no, it depends on the number of terms in the series. So this particular series has 12 terms, but a series can have 20 terms or 5 terms or 100 terms. Okay, so it just depends on what they give you. Okay. All right, let's go down and have a look. All right, so determine the sum of each geometric series using an appropriate formula, which is this guy over here. All right, and you can choose. Are you going to do question A or are you going to do question B? All right, so you are calculating SN. All right, so we're going to give you 5 minutes and then we're going to talk about the answers.
Go and Banana, you can do A, that's okay. And please note, everybody, it will be nice that if you're not talking to Teacher Leah or myself, please always make sure that you are muted. Okay, so we don't hear the background. Like this, we don't distract other students. Let's go. Let's go. The time is ticking and we're getting to an end. And I see Amashle with an answer there. Let's go, my pebs. Let's go. So Teacher Leah will tell us when it's time. Okay. And then if you want to answer, you can raise your hand or you can put on the chat. She also prefers that also.
Yeah,
Fine.
that's fine. No problem at all. Okay, so there's a whole lot of people giving an answer for the first one. Okay, cool. That's great. We've got 2 minutes left.
Ooh, let's go, guys. You still have an opportunity to write it down and calculate and see what you get. You go, girl. I see Tsogofatso is really working hard. I see you calculating. You go. And Tabile, I'm not sure what's going on there, but hopefully you are following. Shouting out to you while we wait for this 2 minutes. And CK, hopefully that hand is to give Teacher Leah some answers.
No, most of the answers that are popping up in the chat look really good.
Hi, guys, we are on the right track.
You
Teacher Leah
are.
likes our answers, my people.
Oh, I do like your answers. Okay, so that was really well done. A lot of you are providing an answer of 728,96 for the first one, which is correct. So just setting that out for you, sum to 9 should have been 2/27. Then your R was equal to 3. So it's 3 to the power of 9 minus 1. And that was all over 3 minus 1, which is where the 728,96 came from. So that was perfect. As far as B was concerned, I've seen a lot of correct answers there as well. Let's just have a look. Naledi, you got 53 for A. No. Let's just do this. Okay. All right, and then in part B, what we would have done is the sum to 10 terms is equal to our A value is -64. Our R value is -1/2. Okay, remember when you substitute, you've got to substitute in brackets and put exponents on the outside. Okay, very, very important, because if you don't do that, you're going to change the signs of your answer. Okay, and then down at the bottom, R -1, and then here you should have had -42,63 if you press the SD button. Okay, so each of those would be out of 2, 1 mark for subbing in and 1 mark for the answer. Okay, so from what I've seen, most people have managed to do that correctly. So that's looking really, really good. So that's just calculating SN, subbing into the formula, and then working out what the answer is. All right. Good job, everybody. Well done. Yes, Faheen, that's perfect. Okay, let's go and have a look at another question. All right, so here in this example, before we move on, sorry. Are there any questions?
Lebohang, do you want to ask your question? You can unmute and ask ma'am.
Ma'am, may you please explain B for me, ma'am? I don't understand how you got -42.63.
Okay, so which part do you not understand? Where are you struggling to understand this?
I got lost from the beginning because I just got the network right now.
Okay, so we're just subbing into this formula, okay, which is our geometric sum formula. So that's what they're asking us to calculate. So the sum to 10 terms. A is always our first term. So there's A, there's our first term, and there we've gone and subbed it in here. Then it's our job to work out the value of R. R is always term 2 divided by term 1, or term 3 divided by term 2. So you're going to take 32 and you're going to divide it by negative 64. That's where minus 1 over 2 comes from. All right, so R, this value over here, R, is that value over there. Okay, then again, they told us to 10 terms. So that's why it's to the power of 10 minus 1 over R minus 1. And there, oopsie, I've used turquoise for
Thank you very
R.
much.
There is R again. So I'm just subbing in. Okay, put it on my calculator and work out my answer.
Thank you very much, ma'am. It helps.
It's a pleasure. It's a pleasure. Absolute pleasure. Okay, if there are no other questions, then what I'm going to do.
I think Nicole has a question.
Oh, sure. Oh, sorry, Nicole, go for it.
Hey, ma'am. I
Hello.
just put the equation into the calculator, but
Nicole, you've disappeared. I don't know if you can hear us.
You have to unmute Nicole. I think Nicole muted herself by mistake.
Oh, okay.
Nicole, you have to unmute.
ma'am.
There we go.
Go for it, Nicole.
I was asking, I just put the equation into the calculator right now, but then the answer gave me negative 42,71.
Ah, okay. So you are doing, did you put brackets around the minus half?
Oh no, ma'am. I just put brackets around the 10. That's the.
Okay.
Yes,
All
ma'am.
right. So you've got to put brackets around the minus half, because if you don't, that's how it changes your answer.
Okay, ma'am.
Okay. So you've got to substitute using brackets. All right. Very, very important.
Thank you, ma'am.
Okay, Nicole, no problem. All right, so let's go on and go and have a look at the next example. All right, so here we are finding the sum when the number of terms is not known at first. Very, very important. So let's have a look at what a question like that looks like for us. So they say to us, calculate the sum. So again, they're implying that we have to use an SN formula of the following finite series. Okay, so the word finite means that it comes to an end. All right, so 0,25 is the first term of the series. 0,5 is the second term of the series. What is 256? Is it an SN or is it a TN? Put it into the chat. What do you think? Is 256 an SN or a TN?
Hello, ma'am.
So most of us are saying TN. Amulekani?
Can you please repeat again?
Okay, so I was asking whether you think 256 is an SN or a TN. Is it a sum or is it a term in the series? What do you guys think? And most of you on the chat have said the correct thing. 256 is a TN. It is the nth term. It is the last term. So this is where the series terminates. This is our last term. Okay, so in other words, it is the nth term of the pattern. When they say to us, calculate the sum, they want us to use this formula. But we can't just substrate into this formula because now we've got two unknowns. Have a look at this, all right? So they want me to calculate the sum, but I don't know the sum to how many terms, all right? So this is an unknown. I know what A is. I know it's 0,25. I know what R is because I can say a half divided by a quarter. So if I take a half and I divide it by a quarter, that means that R is equal to 2. So I can work out what that is. I don't know what N is because I don't know the number of terms in this particular pattern. Minus 1 over R minus 1. This is the problem, okay? Because both the question and the number of terms are unknown. Can I solve the two unknowns using only one equation? No, I can never do that. I can never solve for two unknowns in one equation. So that means in this situation over here, if I want to answer this question, I need to know the number of terms in the pattern, right? And that means that I have to use my nth term. Okay, so in other words, I have to sub into this formula over here that I'm putting a little blue star by. 256 is Tn. A is 0,25. I know what R is. It's 2 to the power of n minus 1. So now I have to solve for n first. What's the first thing I need to do to both sides of my equation? Remember, I want to isolate my base. I want to get my base on my own. So that means that I've got to get rid of, I've got to get rid of this number that's being multiplied by my base. So I must divide both sides by 0,25. So I'm going to take 256, divide it by 0.25, and that leaves me with the number 1024. So I now have 1024 equals 2 to the n minus 1. I have to write 1024 with base 2. So I can use the factorizing button on my calculator, and it tells me that 1024 is 2 to the power of 10. Now that I have made my bases the same, got base 2 for both of them, I can work with my exponents. And that means that n is going to be equal to 11. All right, now somebody did put that in the chat. Yes, good. Now lady said divide both sides by the decimal. Yes, 2 to the power of 10. Yes. Homolemo, n is equal to 11. 100% perfect. Okay, so all I've done now is worked out this bit. I've worked out the number of terms in the pattern. There are 11 terms in this particular series. So now I can go back and I can sub in here. I am calculating the sum to 11. All right, so I must set it out like this. Let me just get rid of that. The sum to 11. And again, I know what this is now. I know that it is 11. Okay, so let me just grab this. Faheen, I'm going to take your question now. And then there we go. Okay, so there's one extra step in these sorts of questions because you first have to work out the number of terms in the series before you can actually go and calculate the sum. Okay. All right, let's just work out what the answer is. You guys should be getting 511,75. Let's just check the chat and then we can do questions. Yes. Yes, yes, yes. Lovely, everybody. Well done. Okay, so Faheen, you had your hand up. What did you want to ask?
No, ma'am, I'm okay. I just want to answer. I'm okay.
Oh, okay. All right. Oh, good. Okay. So I'm just checking in now. How are we all feeling? Is it a thumbs up? Are we feeling good? Thumbs down? If we're not understanding, how are we feeling? That's good. Lovely answers coming through. Nice. Oh, that's awesome, guys. Oh, I'm so pleased. Brilliant, brilliant, brilliant. Yes, Faheen, n was equal to 11. Good to me. Thanks, Pumalela. Lovely. Okay, so now you guys are going to try one by yourselves. I'm going to move this down. There we go. So you're going to calculate the number of terms in the series and then the sum of the series. Yes, Faheen, what's up?
Ma'am, can you just go up a little bit because the other question ain't completed now. Just stop. Whoa, stop.
Okay.
Stop me. Please.
Sure.
Stop me. Thanks, ma'am. I just need to get down. Thanks.
Okay, we'll take a screenshot.
Yeah, it's to take a screenshot. Hey, Farhan, if you take a screenshot, then it goes faster than writing. Oh, that was so cute.
Okay, are you
Okay,
sorted,
ma'am.
Fahim? Oh, okay, no problem. No problem. There we go. All right, guys. So again, I'm going to give you about 5 minutes. Hopefully you can do it a little bit faster than that, but let's see.
Remember, let's mute while we are busy not talking to Teacher Leah. We can mute ourselves. And I'm sure that you guys are just getting into this question. Let's go.
Okay, so someone's popped something into the chat. Okay, so all right, looking good. Good. Okay, I am going to go through it with you, Khumulemo. Okay, number 2. All right, so let me start that now. All right, so as far as A was concerned, we know how many terms are there in the series. So this over here represents the nth term. Okay, it represents Tn. So we're going to take minus 1 over 32, make it equal to A. A is negative 64. R is going to be equal to a half to the power of n minus 1. Did you get that far, Khumulemo? And then you've got to divide both sides by 60 or by negative 64. And that gives us 1 over 2048 is equal to 1 over 2 to the n minus 1. So you can write 1 over 2048 as a half to the power of 11. Okay, is equal to a half to the power of n minus 1. And now that we've made our bases the same, we can equate our exponents. So if n minus 1 equals 11, it means that n is going to be equal to 12 in this case. All right, so that's what you should have done for part A. All right, using the Tn formula to get n first, because we can't solve two unknowns in one equation. All right, so that's why we've got to do that. No problem. All right, now part B, and I see a lot of you have put correct answers in for that as well, so that's really encouraging. We know that we are calculating the sum to 12. So now we're calculating the sum to 12 is equal to A is equal to -64. We know that R is equal to a half. We know we've got 12 terms in the series, -1, all over a half minus 1. And then hopefully we're all getting the same answer for that as well. Let's just check what that was. The other thing that I want to do is I also just want to show you guys where your marks would be allocated, because there are certain steps that you absolutely have to show. Let's just do this. Okay, so I'm getting an answer. I hope you guys are getting the same as me. I'm getting -127,97. Okay, so in matric, it's very important to show that you have subbed in. You get an accuracy mark on this line where the bases are the same, and you get a mark for your answer. Again, a mark for subbing in and a mark for the answer, like so. Okay, so now if there are any questions, you're welcome to go ahead and go and ask. I see Fahim, you had your hand up. Go for it. Okay, Khotatso, I see you're asking a question. Where is the 11 coming from? Okay. No, truly you don't, but you've got to set it out in the correct way. All right, so if you do use logs, not everybody would have used logs yet, but I can show you how you would have to set that out. Did I make a mistake there? Let me just double check. Oh, no, I didn't make a mistake. Okay, so some of you were saying, where does the 11 come from? So 1 over 2048 is a half to the power of 11. Okay, so what you have to do is you can't put 1 over 2048 onto your calculator. You can only put 2048 onto your calculator, and so that would give you 2 to the power of 11. So you need to know that you've got to write the bases as the same. Okay, so that's why it's 1 over 2 to the power of 11. That just helps you to factorize the number. Okay. All right, now Thuli, if you used logs, so that would replace this step. Okay, so Thuli, you would have to write that n minus 1, the exponent, equals the log of the base, which is 1 over 2, and then you'd have to put in the number over here. So 1 over 2048. Okay, so that's how you would set that out. Okay, and then you'd end up with 11 there. So it would be n minus 1 equals 11, and then you would have n equals 12 as well. Okay, so yes, you're welcome to use logs once you know how to do so. But if you haven't got to that step yet, or haven't got to that part of the syllabus yet, it's not the end of the world. Okay, so hang on a second. Clintina, Johannes, when you say, is there a way you could perhaps download this video? Don't stress. All these videos are recorded and they're uploaded onto our website within 24 hours. So if you do miss something, it's all there. Okay. Yes, Tapelo, it's fine if you put your answer as a fraction. Pleasure, Clintina, no problem. All right, so your answer is a fraction. You don't have to press the SD button if you don't want to. If you want to leave it as a negative improper fraction, nothing wrong with that either. Okay, are there any other questions anybody wants to ask me before we go on?
Going twice, going once. See, we can go on still, eh? We can move on. My people are fine.
Oh, good. Okay. All right. Lovely. So let's go and have a look. Okay. So in the next example, this is different again, because now here we are finding n when the sum is given. Okay, so in the previous example, we were finding the sum when n wasn't given. Now we're finding n when the sum is given. Look at the language of the question. See how it changes. It says to us how many terms. When we see the words how many terms, straight away that's an implication that we need to solve for n of the geometric sequence cool will add up to. So when they use the words will add up to, they are implying by the English that 349, 525 is an SN. Okay, it's not part of the pattern because how many terms of this sequence will add up to this number, right? So they've given us the SN, how many terms they want us to calculate N. Again, we know what A is. All right, we see that A is equal to -1, and there's our A over there. And of course, we can work out what R is. R in this case would be equal to, hopefully everybody's okay with that, R would be equal to -2. Okay, now I see there are some hands that have gone up before I have done the example. What I'm trying to do, just to try and make things run a bit smoother, is just to do the example first and then take questions. So if you've got a question and I haven't answered it in my explanation, then please, by all means, put your hand up again and we will certainly come to you when we're done here. Okay. All right. So let's go and sub into our SN formula. So I'll just put the formula here. SN equals A, and here we've got R to the N minus 1 over R minus 1. I don't have to write that first, but I'm just explaining step by step. Okay, so we've got our SN. We know that it is 349,525 from the language of the question. We know what A is, our first term. It's equal to -1. We know what R is by dividing term 4 by term 3 or term 3 by term 2. All right, so that's going to give us -2. Remember to put it in brackets to the power of n. N is what we're solving for because the question said how many terms? -1 over R minus 1. So in this case, it would be -2 minus 1. So now I have just subbed into my SN formula. I want to try and isolate the base. So what I'm going to do is I'm first going to cross multiply. I'm going to multiply my denominator over here with this number over there. Okay, so I'm going to cross multiply -3 with 3,400, sorry, not 349,000, I beg your pardon, sorry, -3 times 349,525, and that leaves us with a big number. It leaves us with -104,875 is equal to -1, and then in brackets, I've got -2 to the n minus 1. Okay. What I can do now is I want to get rid of this -1. So if it was another number, I would divide both sides by another number. Of course, it's -1, so I can divide both sides by -1. Essentially, what that's going to do is if I divide this by -1, then that's going to become a positive number. Does that make sense to everybody? Okay, so dividing both sides by -1 means that my negative is now gone. These brackets are gone as well. And now I need to take this term, -1, over to the other side. Okay, so I've got to add it onto the other side. So this number is going to become 104,856 is equal to the power, is equal to -2 to the n. Right. Now, this is really important. if you are working with a base that is a negative, normally we don't see that. Certainly in functions, we don't see it, but in sequences and series, we do. You have to make the bases the same. So you absolutely have to make this -2 on this side as well. Okay, use your fact button to work out 1 + 1. Use your fact button to find out how many times or what the exponent is going to be. Okay, so shift fact, we get to the power of 20. So because this is an even number, because this exponent is an even number, our final answer ends up being positive. So we know we're on the right track. And now again that we've made our bases the same, we can equate our exponents. So that means n is 20, which somebody actually already said in the chat, but there we go. Okay, all right. So now, are there any questions? Okay, so Mikhail, I see you asking me to explain the cross multiplication again. All right, so Mikhail, what you've essentially got is a situation where you've got a fraction. So this number over here can be put over 1. So in other words, if I have got something like x over 3 equals 10 over 4, if I have a fraction equals a fraction, I can cross multiply. So it's like multiplying both sides by both denominators. So I'm going to say 4 times x is 4x and 3 times 10 is 30. That's what happens when I cross multiply. Okay, so I can use cross multiplication as a method to solve equations. All right, let's see who else has got a hand up. Lungile, go for it. Yes, so 1048,576 is positive, but remember I added 1. Remember the 1's got to go over to the other side.
Madam,
Yes, Lebogang.
from you see from
Sorry, I missed that. Do you want to ask again?
you lost me from where we got 1048,575. Do you mind explaining again?
Not a problem. Okay, so I see there's quite a lot of questions here. Sure, let's just see. Okay, all right. What I'm going to do is I'm going to explain this question again because I see there are a lot of people that are asking questions about it. This is a little bit more difficult. All right, so there's the question again. Let's just get rid of this. So the difference between this question and the one that we had before is that here they're asking us to calculate n, but Sn is known. All right, so before we couldn't go and sub into our Sn formula because we had 2 unknowns, whereas now we don't. We've only got 1 unknown. So from the language of the question, they are implying by the words will add up to implies that 349,525 is the Sn of this particular sequence. We know what A is. We see that A is equal to -1. All right. We can also work out R very easily by dividing a subsequent term by the prior term. So 2 divided by -1 is the same as -4 divided by 2. Our answer would be -2. So R is equal to -2. When they say to us, how many terms, that means you need to solve for n. All right, so when the question is asked, how many terms, it means solve for n, the number of terms in this particular sequence or series. Okay, so now we're going to sub into our SN formula. So the number 349525 is our SN, is equal to A is -1, bracket, R is equal to -2. We are solving for N, our exponent, -1, the rest of the formula, over R -1, so that's -2, -1, like so. Okay, so here I have just subbed in. Okay. The value of my denominator over here, -2 minus 1 is -3. So I can look at this like this is over 1, and then I can cross multiply. So I can do that. So in my first line here, I'm taking -3 and I'm multiplying it by 3491525. So -3 times 349,525 leaves me with that big number, that -1048,575 is equal to -1 times -2 to the n minus 1, like so. So now I've cross multiplied. Of course, when I multiply 1 by -1 times -2 to the n minus 1, it's not going to change. I still need to get rid of what is in front of my bracket. So in other words, I've got to get rid of this. So I'm going to divide both sides. I didn't show this step the last time, but I'm showing it now. I'm going to divide both sides by -1. So that's going to cancel. And here, a negative divided by a negative is going to leave me with a positive. So now I have positive 104,875 is equal to -2 to the n minus 1. I've got to isolate the base. I want the base on its own. So that means that this term needs to go over to the other side. So I'm going to add 1 to the right. I've got to add 1 to the left-hand side as well. So adding 1 to this number means it's now going to end in a 6. It's now going to be 104,857,6, because I've added 1 to both sides, is equal to -2 to the power of n. So let me just discuss something with you guys here on the side, okay? If I have -2 to the power of 4, what does that mean? It means -2 times -2 times -2 times -2. A negative times a negative times another negative times another negative gives me a positive answer. So here I would have positive 16. But if I take a negative base and I raise it to an exponent that's odd, I'm going to end up with a negative answer. -2 times -2 times -2. A negative times a negative is a positive. A positive times a negative is a negative. So here I'm going to have a negative answer. So when you've got a negative base and your exponents are even numbers, you're going to end up with a positive answer. If you've got a negative base and your exponent is odd, you're going to end up with a negative answer. All right, so now here I have to write this number with exactly the same base. I can't change the base to +2. I'm not allowed to change the question, all right? The base is -2. So I have to write this number with a base of -2. Okay, when I put this into my calculator, I press 1048576, and then I must press the equals button. And then I press Shift, Facts, and it tells me that this is 2 to the power of 20. But I know that I'm working with negative base 2. So I've got to keep my negative base 2 to the power of 20. Because 20 is an even number, I'm going to end up with a positive answer, which is what I want. Okay, so equals -2 to the n. Now that I have made my bases the same, I can equate my exponent.
The calculator thing of shift back, if my calculator is a sharp calculator, how do I do it?
Lebogang, that is a very good question. I don't know. I do not ever work with a sharp calculator. Yolanda, do you ever work with a sharp calculator?
No, only
Okay.
the Casio that I know. Yeah.
No, also I only know Casio. So yeah, Lebogang, I don't know, but I think what you should do is go and ask your teacher at school tomorrow to show you with your sharp calculator. If I had one in front of me, I could probably work it out, but I don't. I've only got Casios here at home.
Okay, ma'am, no
Sorry.
problem.
Sorry, Lebogang. Okay,